All right, for question 5, we've moved into the different set of data. We're in part 2 data, and this question calls for the HUC10 polygon shapefile and the slope layer that was calculated from the data set called elevations. The question is to find the name of the watershed that has the type closed with the lowest median slope. So because we're working with a bunch of features here, we've got a raster data set and the polygons. This is another surefire use of zonal statistics as a table. So hopefully you guys are catching on that I am really trying to get you comfortable with going to zonal statistics as a default. It's really effective, and I'll show you some tricks in a second. But what kind of good habit am I trying to instill with this question possibly, besides zonal statistics? And that is that you have to inspect your data. You should be looking at the attribute tables, be curious about, resolution and extent. We've got different scales of data and different extents. And here I gave you a slope data set that doesn't cover all of the watersheds. So, this is what you have to work with. And if I ask you for the watershed that has the lowest median slope, can you include these that hang off the edge? And the answer is no. No, you cannot. So this would be a question you'd go back to your advisor or your boss and say, do you want to include all of the watersheds? And if that's the case, I need to pull more data. Or do you want me to just use the watersheds that are covered by the slope layer? Because you can't assume anything about what's going on here. You can't, assign no data to these cells because you don't know what's happening here. You can't assume that the median or the average is going to extend across here. So we are going to remove these. And I would do that by just selecting them like this and using the Shift key. Looks like that guy's in there all the way. And that one and that one. And because I don't want to have to unzip this data, I'm going to switch the selection and make a copy of the remaining ones. So switch it so that we have all the good polygons selected. And then I'll just make a copy of those features. All right. Okay, I'll call them the good ones. All right, turn off the other ones. Make sure my selections are cleared. And we don't need that guy anymore. So here are the watersheds that are actually covered by the slope raster. And that's good news. Okay, so if we look in the attribute table, we have a bunch of columns that don't mean a whole lot. Here's the HUC10 number. We've got a unique name. Here's that HUC type closed, and I include with the data that I gave you guys, I included a screenshot that explains what these are if you watershed-minded people are curious. But let's jump in and run the zonal statistics and then go from there. So zonal statistics as a table. Remember, we're skipping the first words here and we're looking at zone data. So our zones of interest are our good HUC10s. This is the key to zonal statistics. So you already saw that we used this to separate out the active and the inactive beaver dams when we ran the analysis for the slope within 50 meters. So you can use this if you find a non-unique identifier, something like states, where every single watershed has the same value. If you put states in here, then zonal statistics is going to summarize the slopes within all of the watersheds collectively and give you like the full on summary, statistical summary. But if we want to get a mean, a median, average, whatever, for every individual watershed, which is what we want because we want to know which closed watershed has the lowest median, then what was I going to say? Then we want to put in a unique identifier here. And so we could make sure that the name is actually, there's only 29 of them, so we would expect these to all be different, and I think they are. Yeah, it looks like they are. We'll close this one because we don't want that one anymore. We just want to work with our good ones. We'll open the attribute table. I'm going to just be straightforward about it and sort this ascending. And select all the closed watersheds. All right, and I'm going to go ahead and make a copy of that. I mean, you can see that I have my ways of doing things. You don't have to do them this way. If you wanted to clean up this data set, you could reverse this and just delete the ones that aren't closed. That's completely fine. I just, these are my habits, and you can do with them what you will. All right, so our input features our output. That makes sense. We'll just give this the C so we know what they are. Okay, clear selection, turn off the inputs. Right, we've got the remaining watersheds in here. So these are all closed and they're covered. So let's run zonal statistics again. All right, that looks good. The zone field, we still name slope. I named the output table, looks good. Oh, sorry, this is wrong. We need to switch it to the C. All right, there we go. And run. All right, so now we would expect to have 1, 2, 3, 4, 5, 6 records in here. We do, that's good news. And then just sorting here. Turns out we end up with the same watershed, hole in the rock. So you're going to report the name, not the value here. But if you were to report this, is 0.1% a reasonable precision? I would say at most, yes. So 2.3% rise. You know, these values just aren't correct when we're dealing with a 10-meter DEM. We can go back to the DEM lab and look up the vertical accuracy for the USGS 3D elevation program data sets. But considering that we're taking a 10-meter cell that's already been interpolated and then running slope, we're going to get rid of all these significant digits responsibly. All right, see you for question 6.